Hello viewers, in this tutorial we will learn the another type of regression model, that is LASSO regression or L1 regularization. Statistical analysis frequently employs regression models. One such application is simulating the expected risk of a foreseeable event. Unfortunately, using standard regression techniques to create a model from a set of candidate variables often results in overfitting. For example, adding too many variables, and overestimation, that's optimism biases of the model's variability. To explain the observed variability using the included variables, a kind of linear regression known as lasso regression or least absolute shrinkage and selection operator incorporates a penalty proportional to the true amount of the magnitude of the coefficients. This penalty makes certain coefficients absolutely zero, allowing for a variable selection and regularization to increase the model's interpretability and prediction accuracy. To perform lasso regression in R, we need two packages, that is glmnet and treverse. glmnet package is used for model building and the treverse package is used for data processing. So I have these two packages in my computer, so I'm not gonna install it. So I just run the command to activate these packages. So run it. Okay, the package is loaded. Then treverse. It's taking time for being activated. Okay, the package is activated now. So we will use the empty cards dataset, which is built in R, to perform the lasso regression model in R. So we run this command to load the data. So run it, data then empty cards. Then we want to see the first 6 observation of the data by using the command head. So run it. So these are the first 6 observation of the data. The data contains 11 variables and 32 observation. Here is showing first 6 observations. So this MPG, that means miles per gallon, CYL cylinder, DISP disposal, and others variables here. So we are considering MPG as a dependent variable in our case. So as we said in the description, that lasso regression gives a penalty to the coefficients equal to 0. That means when we fit multiple linear regression model and we get in summary results all of the coefficients, all of the variables have some coefficients, but in lasso regression model we will not get all the coefficients for each variables, because it gives a penalty that if the variable is not necessary for our model, the lasso regression gives a 0 for the variable as coefficient. So let's define the predictors and dependent variables. So we define the predictors as x by mentioning as matrix. So we use this code. So run it. Okay, then x defines the group of predictors or factors used for the regression model as a dependent variable, and y indicates the MPG, miles per gallon variables, which is our dependent variable. So we run it. Okay, so before going to fit a lasso regression model, we fit a linear regression model to see the results first. Okay, so we name the model of linear regression as MD1 and write the LM function for linear regression model and y on x variable. Okay, run it. Okay, the linear regression model is fitted. Now we want to see the summary of the model. So we write ASU double MARE summary, then model name. Okay, Rani. So here is the summary of the model, our linear regression model summary. So if we take a look on the summary of the model, we see that all of the predictor variables we used in the linear regression model have some coefficients. So the intercept is 12.30337. This is the intercept alpha value. Then these are the beta values or the coefficients of the independent variables. So all of the independent variables have their corresponding coefficients. So now let us fit the lasso regression model. So to fit the lasso regression model, we need to set the seed 1, 2, 3 for reproducibility. So we run it. So we set the seed 1, 2, 3. Then we will fit the lasso regression model. Initially, take the value of alpha equal to 1. So run it. Okay, we have fitted the lasso regression model. Then we will plot the model and see the lambda value. So run it. Okay, so this plot shows the coefficient versus the log lambda value. So we will take the best lambda value that fits the model. So we will perform the cross validation to select the lambda that is appropriate for the model. So run it, and we again run the CV of lasso and run it. So we found the lambda, minimum lambda is 0.8007, index 21, measure 8.0. So we will use the lambda that is best fitted, or 0.8007 here. So we need the best lambda value. So first of all, we plot the CV of lasso regression model here. So we run it. So these are the log lambda value and their mean square error value here. So what is the best lambda for our regression model or lasso regression model? To see this, we have to run this code, the best lambda from the lasso model. We run here. Initially we have to take the minimum lambda value, so we run it. Okay, the best lambda value, which I said 0.80070336. Okay, so we have, okay, now we have the best lambda value, so we can fit the final lasso regression model using the glmnet function and using the alpha value is equal to 1. So we, using this command or code, we can fit the final lasso regression model. So we fit the model. Okay, run it. Okay, now let us see the coefficient of the model. We run here. So this are, so here's the summary of the lasso regression model, and we can see the coefficients of the predictors, and we can see here that not all of the predictors have their coefficients, only a few of the predictors have coefficients here, because these predictors or independent variables are important for the interpretation of the model. So let us run this code to see the coefficients of the models in a data frame. So we use this code. So we are running this code here. Okay, so we can see here the coefficients of the model, and from the empty cars dataset, using the MPG, miles per gallon, as a dependent variable, we fitted a regression model, and we find the summary of our model from the lasso regression model, and we see that the three variables, cylinder, horsepower, and WT, that is weight, are the three most important variable for predicting the miles per gallon variable, and the other variables are not important, and the lasso regression model gives a coefficient of equal to 0 to that predictors. But when we fitted the linear regression model, we see that all of the predictors have their own corresponding coefficients which are not appropriate and which is very complex to interpret the model, because not all of the variables are important to predict the dependent variable. So this is the differences between lasso regression and linear regression model. Lasso regression model allows variable selection and regularization to increase the model's interpretability and prediction accuracy. Thank you very much.